we're going to learn about trigonometric equations. And so basically what this is it's combining algebra with trig. And I love algebra. So these two sections are probably two of my most favorite sections. Unfortunately, they have to come at the end. But anyway, do you remember back in chapter 4 when we graphed all of these trigonometric functions and their inverses? Well, remember when we had our sine curve? And we only went from 0. I know this graph goes from negative 2 pi to 2 pi, but we only were concerned with from 0 to 2 pi. And so basically we say that from 0 to 2 pi, you can fit one sine curve in there. Okay? So our domain is restricted from 0, including 0, all the way to 2 pi, but not including 2 pi. So, for example, your domain is restricted from 0 to 2 pi. But notice the difference in the symbols. The bracket means that we can include 0, and the parentheses means we'll never include 2 pi. Reason being is because they're the exact same place, and you can't include those twice. Okay, so what we're going to do when we solve these equations, you know how if you have an equation that says 2x plus 3 is equal to, 9, and then you know how you solve for x, you'll minus 3 from both sides, and you'll get 2x is equal to 6, and you get x is equal to 3. And so basically when you solve an equation, you're trying to figure out what x is. Well, in a trigonometric equation, you're doing the exact same thing. You're just trying to figure out what x is. In other words, at what angle do we hit these certain things? In other words, at what angle would x be 3? Which we would never have that. But, so for example, what you're saying is, let's say that x came up to be, let's say that x came up to be, if you're looking at your unit circle, let's say that sine x is equal to, let's just say 1/2. Sine x is equal to 1/2. Now, 1/2 is right here. Okay? So I want to know, on the sine curve, where are we going to hit 1/2? Well, if we draw a line horizontal at 1/2, we're going to hit 1, 2, and possibly, well, that goes outside, so we can't even include that one. Because we have to stop at 2 pi. So we're going to hit 2 times. And x is going to be equal to wherever these hits are on the x-axis. Well, if you look on your unit circle, or if you look at your unit circle in a chart, to me, for the equations, this one's easier, but whatever. Go around your unit circle, and we're looking at sine, and sine is which coordinate if you're looking at your unit circle? Sine is which coordinate? The y coordinate. So if you're looking at your unit circle, go around your unit circle and see where the y coordinate is equal to 1/2. Looking at your chart, just look at sine and go down through there until you see 1/2. Well, I see a pi over 6. I'm assuming that this one's going to be pi over 6. And if I look on further down, I see a 5 pi over 6. So this one's going to be 5 pi over 6. And when you're solving a trigonometric equation, that's what you're doing. You're trying to figure out where on this sine curve am I going to equal 1/2. It could be 1 time, it could be 2 times, it could be 3 times. We're going to do one that could be up to 6 times. Okay? It could be 0 times, especially if you're outside the range. So when you solve an equation, that's what you're doing. You're trying to figure out the x values of sine where you're going to get 1/2 or whatever our case may be. Okay, so this is what you're going to do. You're going to decide whether the equation is linear or quadratic. That's the difference between what I just did, 2x plus 3 is equal to 9. That's linear because I don't see any exponents. Versus something like x squared plus 3x plus 4 is equal to 0. That's quadratic because I see a squared term. Okay? So decide if it's linear or quadratic. If it's linear, you're just going to solve it just like a normal algebraic equation like I showed you a while ago. If it's quadratic, you're going to have to use some of your tricks, preferably factoring, okay, in order to solve. If only one trig function is present, solve the equation for that function. If more than one trig function is present, then that means you're going to have a quadratic probably. And you'll just have to factor and set them equal to 0. And sometimes you can try using identities to change the form. If I just cannot figure it out, I'll look for an identity. But most of the time, I can figure it out. Okay, so here's your first one. Sine x is your x. Okay, so if you're thinking in algebra terms, sine x is basically your x. And you want to get sine x by itself. So you know your algebra rules. You're just going to minus 2 from both sides. So you're going to get sine x is equal to 1. Sine x is equal to 1. So what you're going to do is you're going to look at your unit circle or look on your chart and you're going to look to see basically what I'm asking you is this. Where does the sine curve hit 1? Where does the sine curve hit 1? So if you go down through there and look at your domain, we're in radians, so your answer should be in radians. So I see that it hits 1 at pi over 2. And if I keep on going, it doesn't hit 1 anymore. So your answer is just pi over 2. Because you know on the sine curve, the only place it hits 1 is right here. And apparently, that's pi over 2. Because, I mean, here it hits negative 1, but that's not what we're asking. We're asking for 1. Okay? So, that's what you're doing. So, your answer is just going to be pi over 2. Alright, so let's look at this one. Now, this would be something like 2x plus 1 is equal to x plus 3. Algebraically, could you solve that equation for x? You're going to do the exact same thing with trig. Okay? So we're going to minus secant x from both sides. And I'm going to minus 1 from both sides. Just to kind of separate things to get the secant terms and the constant terms. So we'll have secant x is equal to 2. So I want to know, and I kind of remember in your head what secant is. Secant is the inverse of cosine. So remember, if we have our secant curves, it's something like this and like this. Actually, that's cosecant, but you get the idea. So 2 is definitely in our range. 2 is definitely in our range. So if you look, now the unit circle is going to be hard to look for that because you're going to have to take the reciprocal of your x coordinate. So I would say look at this chart. But if you're going to look at the unit circle, look for anything where x is 1/2, so take the reciprocal of it, okay? But my domain is in radians, so my answer is going to be in radians, so I'm going to get pi over 3. I'm just looking down at my secant, I'm looking down through there, and every time I hit a 2, I look over and look at the radians. So I'm going to keep on going down, and I hit 2 again at 5 pi over 3. So my secant curve hits pi over 3 and 5 pi over 3 at 2. Every time it hits 2, that's where it is. Now again, if you're looking at your unit circle, look at pi over 3. Your x coordinate should be 1/2. Take the reciprocal of it. Okay. Secant is the reciprocal of cosine. Okay, so let's look at this one. This one's quadratic, so I know some factoring needs to go on. This is something like 2x squared minus the square root of 3x. Well, I know that there's an x in common. And so that's what I'm going to do. I'm going to factor out a cosine x. So if I factor out a cosine x, I'm going to have 2 cosine x minus the square root of 3 is equal to 0. And when you do that, all you're going to do is take each one of these and set them equal to 0. So I have cosine x is equal to 0. And I have 2 cosine x minus square root 3 is equal to 0. Well, cosine x equals to 0, that one's ready to go. I can already say that if I could look at cosine and go down through there, my interval is in radians. So at pi over 2, cosine is 0. And there should be one more, yep, 3 pi over 2. Now the one on the right, I'm going to have to do a little more solving, so I'm going to add square root of 3 to both sides. So I'm going to have 2 cosine x is equal to the square root of 3 and then divide by 2. So I need to know where cosine x is the square root of 3 over 2. So I'm going to go back to my cosine column and I'm going to look down through there. Radical 3 over 2 is pi over 6. X is going to be pi over 6. And there should be one more. Yeah, 11 pi over 6. And so here you have 4 answers. You have 4 possibilities. Because cosine is going to, what I'm looking for is I'm looking for where does this cosine curve from 0 to 2 pi hit 0. So it hits 0 here and here, which is going to be pi over 2 and 3 pi over 2. And I also need to know where it's going to hit the square root of 3 over 2, which is a little more than 1/2. So we're going to say here and here, which is going to be 11 pi over 6. And, nope, pi over 6. And 11 pi over 6. Okay? So do you understand what we're doing? Okay. This one is quadratic as well, but look at this. Basically what I have is x times y equals 0. So there's no factoring that needs to be going on. I just need to take both of my factors, both things that I'm multiplying together, and set them equal to 0. And if you take the square root of both sides, I want to know where is sine is 0 and where is cosine 0. Well, sine is 0, and look, my domain changed. Now we're in degrees, so your answer needs to be in degrees. So sine is 0 at 0 degrees and 180 degrees. And it's also 360, but remember you can't duplicate because 360 and 0 are the same thing. So then I also want to know where is cosine 0, and that's going to be at 90 degrees and at 270 degrees. So those are your 4 answers there. Okay, let's look at this one. This one's actually kind of comical because a lot of people want to do things to this one when really and truly you don't have to. What does an equation mean? What does the equal sign mean? The left side equals the right side. So basically what this question is asking is where do the sine and cosine curves equal each other? Where do they overlap? That's basically what they're asking. They're asking where do they equal each other. So if I take this one, and you can also look on your unit circle, and if you go down through there and you just look at where they're equal to each other. So where are they equal? So x would be at, I'm back in radians, so pi over 4. And also, there's one more. 5 pi over 4. So this would be pi over 4, and this would be 5 pi over 4. Where are they equal and opposite? So no algebra needed on that one. Some people will minus sign from both sides, and then I don't know what they do. They square it, and then they come up with a, yeah, I don't know. Okay. This one, we have a quadratic, so what comes to your mind? If you have a quadratic, factor should come up to your mind. If you have a quadratic, you should want to factor. So this one, it's actually a pattern, but I'll go ahead and do it out. This is like looking at x squared plus 2x plus 1. And that's going to factor into x plus 1 times x plus 1. Or what I like to say is x plus 1 quantity squared. So this one's going to be cosine x plus 1 and cosine x plus 1. But again, what I like to do is I like to write it as cosine x plus 1 quantity squared is equal to 0. That way, instead of setting 2 factors equal to 0, all I have to do is take the square root. Square root of 0 is 0, so I'm going to get cosine x plus 1 is equal to 0, minus 1 from both sides, and I get cosine x is equal to negative 1. So then you go to your unit circle, or you go to your chart, and you go down through there and you figure out where cosine x is equal to negative 1. And we're in radians, so it's at pi. So x is equal to pi. Are we good? What do you think? This is not that bad, right? It's probably one of the easiest things we've done all year. All semester. Okay, what do you think? What is the first thing you see? What's the first thing I told you to look for? Linear or quadratic? What is this one? Quadratic. In order to solve a quadratic, it's got to be set equal to 0. So let's minus a sine x from both sides. Minus sine x from both sides. So we're going to have 2 sine x, 2 sine squared x, minus sine x. 2 sine squared x minus sine x is equal to 0. Now you can't put those together for the same reason as this would be looking at 2x squared minus x. Those are not like terms, right? So you can't put those together. So what would you do? Factor out what's in common. There is a sine x in common. So we'll factor out a sine x. So we'll have 2 sine x. Now if you factor a sine x out of a sine x, what are you left with? You're left with 1, because you're dividing, right? When you factor out something in common, you're dividing. So that's going to leave you with a negative 1. Take each one of these, set them equal to 0, and as we've already discussed, sine x equals 0, that one's ready to go. So you're just going to look and figure out where x is equal to 0, go to your chart. We are in radians, so at 0 radians, and again at pi. But the one on the right, we need to solve a little bit. And once you solve this, I'm fairly confident all of y'all can solve this. If not, you wouldn't be in trig for sure. Sine x is equal to 1/2. So x is equal to 1/2 is going to be pi over 6. And then there should be another one. 5 pi over 6. And there's your 4 answers. Good job. Okay, this one is quadratic, but there's nothing to factor, right? Because we only have 1 sine x. Well, technically we only have 1 sine x term. So there's nothing to factor. So what are you going to do? Well, get that sine squared x by itself. Sine squared theta, rather, by itself. So we're going to have sine squared theta is equal to 3/4. Now, if you had something that said x squared is equal to 3/4, how would you solve that? Yeah, you take the square root of both sides. Now this is going to get fun. X is equal to the square root of 3 over 4. Can anybody tell me what that is? Split them up. Can't take square root of 3, but square root of 4 is 2. So you're going to have sine theta is equal to the square root of 3 over 2. So what angle is sine, or what angle does sine go through square root of 3 over 2? And we're in degrees. Please pay attention to your domain. We are in degrees, so we're at 60 degrees. Is there another one? 120 degrees. And if you pay attention to your signs, where is sine? This sign is positive. What two quadrants is sine positive? 1 and 2. So is there any sense in looking in 3 and 4? There's no sense in even looking there. Okay. Okay. Quadratic does need factoring. So again, this is like looking at 3x squared minus x minus 4 equals 0. So you would need to factor that. So if I factor that, 3x squared will go in 3x and x. And then 4, I need a negative 1. So I'm thinking 4 and 1, but this needs to be negative, this needs to be plus. Just doing guess check. You can do bottoms up, box method, whatever if you want to. I think we're a little past that, but whatever. So basically you're going to have 3 sine theta minus 4 and sine theta plus 1. Take each one of these, equal them to 0, and solve for sine theta. So here sine theta is going to be equal to 4/3. And here sine theta is going to be equal to 1. Now, can you tell me the range for sine? How high and how low does the sine curve go? How high does it go? 1. And how low does it go? Negative 1. 4/3 is the same as what? 1 and 1/3. That's out of your range, is it not? The sine curve will never, unless you do something to the amplitude, and we're not. Unless you do something to the amplitude, it's never going to reach 1 over 1. So this is gone. That's not even possible. And then what you're going to do is you're going to look through there and figure out where sine is 1. We are in degrees. Thank you. Negative 1. So that's going to be 270. And that's it. So again, if you're good with algebra, this should be a breeze for you. Okay. This is the difference of two squares. You can factor it, I guess, if you want to. It would be something like x squared minus y squared, which is going to factor into x plus y times x minus y. And then if you take each one of those and set them equal, watch what happens. Set them equal to 0, you're going to get x is equal to y, negative y, and x is equal to positive y. So basically, watch this. If I add cosine squared theta, and you'll remember this from a while ago, you're going to get sine squared theta is equal to cosine squared theta. So if you square root them, basically you're asking this time not where are they equal, but where are they equal and opposite. Look, opposite and equal. Where are they equal and opposite? But again, if you want to factor them, difference of two squares, set them equal to 0, you're going to do the same thing. So what you're going to do for theta is you're going to figure out where the two lines cross. Well, we've already done that. We did that back here. So now, not only are we looking at where they cross, we're also looking at where they're exactly opposite, which is going to be somewhere like here, here, and here, and here. So let's look down through our chart or on your unit circle and figure out where they're equal and where they're opposite. And we're looking at degrees this time, so they're equal at 45 degrees. They're opposite at 135 degrees. They're equal again at 225 degrees. And they're opposite at 315 degrees. So basically at all of the 45 reference angles, that's where they're equal and opposite.